Hello viewers, welcome to this tutorial on basics of 16x2 liquid crystal displays. LEDs are widely used to indicate the status, and also it can be used to display the numbers as well as characters. Whereas displaying the graphics or symbols using LEDs will be a tedious task. Whereas we can display the graphics as well as symbols in a much more easier way with the help of LCDs. So that is why LCDs are replacing LEDs to a large extent. And there are few other reasons like declining prices of LCDs. LCDs are nowadays available in cheap price. So it is widely used nowadays. And it has the ability to display numbers, characters as well as graphics. And another important drawback of your LED based display devices is there we need to have a refreshing controller so that the values needs to be sent again and again. After refreshing the memory, it should be sent again to get displayed. Whereas in the LCD, nowadays we have a refreshing controller incorporated into the LCD. So there is no requirement for a CPU to do this job. So there is a separate controller which will be used for refreshing the data onto a LCD. And another important advantage of using a LCD is ease of programming. So these are the several advantages of LCDs. So that is why it is widely used in most of the embedded systems. So now let us talk about 16x2 LCD interface. What do you mean by the 16x2? So 16x2 represents, so there are going to be 16 columns and 2 rows in which we can display our characters, numbers or symbols. So in the first row we can display 16 characters, in the second row we can display 16 characters. So that is why it is called a 16x2. There are other versions of LCDs are also available, 20x2, 20x4, 120x80. So like that we have multiple number of LCDs available and with different sizes. So if we look at the pin details of a 16x2 LCDs, it contains 16 pins. So in the 16 pins, the very first pin is a ground line and the second pin is a supply line. And the third pin is mainly used for contrast adjustment. So contrast in the sense, since it is a monochrome type of display, so in a monochrome the pixel value can be a white pixel or a black pixel, and it can have different shades of black and white. So we can adjust this gray levels with the help of a potentiometer connected to this contrast pin. So by adjusting the potentiometer value, the contrast can be either increased or it can be decreased. So this first 3 pins, ground line, VCC and contrast line, is a power supply lines. So VCC and ground are supply voltages for the LCD, whereas the contrast pin, we connect a potentiometer, thereby the contrast or the gray level of the pixels gets varied. Then we have 3 control lines, which is RS, RW bar and enable. So these 3 control lines are necessary to display any character or symbols. So let us first talk about the data lines and then come back to this control lines. So we have 8-bit data line, which is D0 to D7. So this data line will be used by the CPU to send the data to your LCD. So the LCD, when the microcontroller wants to send some data to LCD, first thing is it should indicate some parameters like in which row it should display the character, whether it should be on a first row or it should be on a second row. If it is on a first row, whether the character should be in the first position or in the 5th position or in the 10th position, so that we need to specify. Same way, whether the cursor is required or not, or whether the command should be something like a character should be shifted towards right or left. So those informations also needs to be sent by the CPU. So it is not like interfacing an LED with a microcontroller. So when we interface an LED with a microcontroller, just by putting the anode to 5 volt and cathode to ground, we can make the LED to glow. Whereas in case of a LCD, it requires the initialization part. So initialization in the sense, we need to specify what type of LCD we are going to connect to your microcontroller, and then we need to initialize the row in which we are going to display the characters, which position, whether I want cursor or not, whether the cursor should be in a blinking state or not, what type of character I am going to display, and how the shifting of characters is going to take place. So like that, we need to send multiple number of commands to your LCD. So there are two information which will be sent by the CPU. One is the command, another one is the data. Data in the sense the actual information which needs to be displayed on the LCD. So the CPU sends either a command or it sends a data. So in the LCD, we have a register called as command register, and there is another register called as data register. So that when the data comes from your CPU to LCD, so the data will be either put into the command register or it will be put into the data register. How it will identify it? With the help of a RS line. So RS line is nothing but a register select line. So register select line means whether the incoming data is related to a command or whether it is related to a data. So if RS line is 0, the incoming data through D0 to D7 will be loaded onto the command register. If RS is equal to 1, then the incoming data into the LCD on D0 to D7 will be loaded into the data register. So RS determines whether the data needs to be placed on a command register or it should be placed on a data register. Next, we have the second line, control line, which is a RW bar, read or write operation. So usually from a CPU, we try to put the data onto the LCD. So it's a write operation. What the CPU reads, if the CPU wants to send some continuous information, then it should ensure that whether the first information which it has sent to the LCD has been properly operated. And after ensuring it, it can able to send the next character. So in order to do that, there is a bit position on the command register, which is the 7th bit position in your command register, which can be read by the CPU. So on seeing, so this 7th bit gives the indication whether the character has been displayed or not. So if it is not displayed, then the CPU has to wait for some time before sending the next data. So it can read as well as write the information. So CPU can write the information or it can read the status of the transaction. Next comes your enable line. So enable line is something like CPU puts the data onto D0 to D7. So it has to give an indication to the LCD. How it can give an indication to the LCD? By making this enable line. So the enable line will usually go from a high to low pulse. So whenever the enable line goes from high to low, then the LCD will understand that okay, some new data is available on D0 to D7. So it will get the data, and depending upon the RS line, either it will put it onto the command register or it will put it onto the data register. So that is the use of having your enable line. So these three lines are called as control lines. RS stands for register select, RW bar stands for read or write, EN stands for enable line. D0 to D7 is called as a data line, and it carries both commands as well as data. So command is identified by the RS line. If it is equal to 0, then D0 to D7 will be treated as command. If RS is equal to 1, then D0 to D7 will be treated as data. Data means the information which needs to be displayed on the LCD. Then the pin number 15 and 16 is the backlight. So this type of LCDs, it comes with different backlight. Backlight in the sense there will be a small LED onto this LCD, so which can be something like a yellow LED, blue LED, red LED. So there are different versions of backlight are available. So we need to give a supply for that LED. So that can be given by this pin number 15 and pin number 16, which is a backlight LEDs. LED power supply. So that gives the detailed information of this LCD. So once we know this connection and what each pins are going to do, then we can easily send the data from your microcontroller to the LCD. So as I said earlier, our 16x2 LCD means we can display 16 characters in each row. So thereby I can have 32 characters. So what will be the configuration of one character? So one character is made up of 5 by 8 pixels. So 5 pixels along the column wise, 8 pixels along the row wise. So each character has 40 pixels. 5 into 8, it will be 40 pixels. So we need to either make a particular pixel to go to on or off. Depending upon that, the particular character will be displayed onto the LCD. So this gives the pin details as I described earlier. VSS is a ground line, VCC is a power supply line, VEE is nothing but this contrast line, which is equivalent to your contrast adjustment. We connect it to a potentiometer, thereby I can adjust the voltage to this pin. Then RS, depending upon either it is 0 or 1, the data coming from D0 to D7 will be loaded onto your command register or data register. Then RW bar is used while writing the data, it will be 0. While reading a data in the sense the 7th bit of your command register. It can be read to check whether the previous transaction has completed or not. Then enable indicates whether the data is available on the D0 to D7. So this enable line will be a high to low pulse. Next, what we are going to discuss is, as I said, the CPU is going to send commands as well as data. So what should be the format of command and what should be the format of data? So for knowing that, we try to understand here. So this is the format of command. So we know D0 to D7, it's a 8-bit command coming from your CPU. So here if I send 0x01, so this is a hexadecimal value, 0x represents hexadecimal value. So which means if this command comes, then it is nothing but clearing the display screen. If 0x04, then decrement the cursor. 0x06, increment the cursor. 0x05, shift display right. 0x07, shift display left. Shift display left in the sense the character will be shifted towards left by one position. Same way 0x08 means display off, cursor off. 0x0a, display off, cursor on. 0x0c, display on, cursor off. 0x0e or 0x0f, display on, cursor will be in a blinking state. And each position has an address in the 16x2 LCD. So for example, in the first row, first position has an address of 0x80. Second position will have 0x81. Next position 82, 83. So like that it goes on till the final position will be your 8F. Same way second row, first position will be indicated by the address C0. Second position will be C1, C2, C3. So like that it goes on till CF. So if I have multiple lines, third line, fourth line, so we can look at the data sheet for the corresponding addresses. So these are some of the commands which can be sent by the CPU to your LCD. So here I have shown different types of LCDs like 16x2 we have already discussed. It starts with the first row, first character address is 80 and the first row last character address is 8F. Second row first character address is C0, last character address is CF. So if I use a 20x1 LCD, then the starting address will be 80, end address will be 93. So remember, this is a hexadecimal number. Then 20 cross 2 LCD, first row will start with 80 to 93, second row will start with C0 to D3. If it is 20 cross 4, it will be 80 to 93, second row will be C0 to D3, 94 to A7, D4 to E7 will be the third and fourth rows. And 40 cross 2 LCD, first row will start with 80 and it will end at A7, second row will start with C0 and it will end at E7. So this is the format of command for initializing the position of an LCD. So now how to display a character? For example, we can, as I said earlier, we can display an alphabet, we can display a number, symbols, some graphics also we can display. How we can display it? With the help of a Ascii codes. Ascii code is nothing but American Standard Code for Information Interchange. So where a binary code represents each and every letters, characters, symbols, etc. So for example, here I have shown the Ascii chart. So Ascii chart is shown in this slide. So here you can see that on the left side I have the MSB part, on the right side I have the LSB part. So for example, if I want to display character A, capital A, then my hexadecimal value will be 0x41. Capital A will be 0x41. If I want to display something like small a, then it will be 0x61. So like that for each numbers, for example 0, if I want to display 0 on LCD, then the ASCII value will be 0x30. So like that each and every numbers, alphabets, then symbols, some special characters will have this ASCII values. So this ASCII values can be used for displaying these characters onto the LCD. So while displaying the characters, the CPU can do two things. One is it can send a data. So first it has to do the initialization part. So after completing the initialization part, the data needs to be sent. So CPU can send the data, wait for some time, then it can send the next data. So that is one way of sending characters to the LCD. Another way is first data will be sent to the LCD, then the CPU has to check the status, whether the data has been displayed or not. That it can check using this D7 bit of command register. As I said earlier, using the D7th bit of command register, which is nothing but a busy flag, which can be read by the CPU. So in order to read this, the RW bar will be 1 and enable will be a low to high pulse. For latching of data, it will be high to low. For reading a data, it will be low to high enable pulse. So by two ways, the LCD can get the data from a CPU. First one is it can get the data from a CPU. After some time, it will get the next data, assuming that everything is working proper and the character has been displayed. In the second option, CPU is going to ensure whether the first character has been displayed or not using the busy flag. Once it has ensured, it will try to send the second data. So that is how the data has been displayed or sent to the LCD by the microcontroller or a microprocessor. So in this tutorial, we have discussed about the just general basic of your LCD, 16x2 LCD. So in 16x2 LCD, we have power supply lines, control lines, data lines. So and how to represent a command, how to represent a data for displaying onto the LCD. Those information we have discussed in this tutorial. So thanks for watching this video. Please subscribe for more technical learning. Thank you.